Look at modern mechanical design. It is dynamic, highly complex, and fully three-dimensional. Yet, when it comes time to communicate how to build these assemblies, that rich data collapses down into a flat, static, two-dimensional line drawing. Despite advances in manufacturing technology, this piece of paper, or its digital equivalent, remains the source of truth. Every dimension, tolerance, and note on the drawing dictates exactly how a part must be produced. But organizations still treat these critical instructions as inactive files. Locked inside static PDFs, this format forces quality engineers to spend hours manually scanning each line just to find a single missing dimension. Design teams hit the same wall. When they need to update an older part, they end up rekeying legacy paper scans into modern CAD systems by hand, one feature at a time, and revision control becomes a manual exercise. Trying to track the exact changes between a revision C and a revision D drawing requires a tedious visual comparison of every annotation. Manufacturing teams are under pressure to accelerate their output, yet the foundational drawings they rely on are disconnected from the automated systems used to build them. Simply digitizing a piece of paper into a PDF does not solve the bottleneck. To speed up the transition to the shop floor, the technical details inside that drawing need to be searchable and structured. GLYPAD addresses this by building a data architecture on top of the flat blueprint. It begins with drawing intelligence. Using AI and optical character recognition, a scanning line sweeps the document to extract technical meaning directly from the geometry and text, removing the need for manual redrafting. Once the data is structured, GLYPAD adds a layer of quality intelligence. The system checks dimensions and geometric tolerances against built-in ISO 2768 standards, or custom company rules. By applying these instant standards compliance checks, GLYPAD catches missing tolerances and manufacturing errors before they cause production delays. The third layer is engineering intelligence. This acts as a partner that accelerates iteration, helping engineers refine designs without sacrificing control. Engineers can use text prompts to generate editable 3D CAD models, receive specific tolerance suggestions, and automatically identify gaps in the design. When those designs change, the fourth layer, change intelligence, manages revision control. GLYPAD generates an engineering-aware chain log that identifies exactly which technical parameters have been modified. It isolates geometry shifts, material changes, datum adjustments, and surface finish modifications between the old and new revisions. By focusing on technical modifications rather than visual discrepancies, teams can assess the impact on manufacturing and prioritize engineering resources using objective data. The utility of the drawing continues after approval. The final layer, manufacturing intelligence, caps the stack to connect engineering designs to production execution. This layer translates the validated drawing data directly into shop floor work instructions. It generates CNC-ready information, creates precise measurement plans, and first article inspection reports based on the approved design. This 5-layer architecture provides the technical intelligence layer that sits underneath the CAD viewer, the QC checklist, and the file converter. It serves as the data foundation for all engineering and quality workflows within an organization. Every drawing that enters the system becomes a structured, machine-readable record that can be queried and updated as a design evolves. This structure allows design, quality, and manufacturing teams to move from an initial concept to a physical part with increased speed and accuracy. Engineering leaders can now transition their static archives into searchable knowledge bases that are fully integrated with modern production systems. By turning static drawings into actionable intelligence, GLYPAD enables teams to move from an approved design to production-ready results in minutes, not weeks.